All right, now let me ask you a quick question. All right, so look, okay, look carefully to the function right here. Look at the parentheses. Will there be a hole? The answer is yes. How do you know? The x minus 1 got canceled, right? The x minus 1 got canceled. So that means the hole must have an x value of 1, because x still cannot equal to 1. Okay? X still cannot equal to 1. And if you want to find out where the hole is at, so hole is x equals to 1. What about the y value? Well, you just plug in 1 to the x values. Okay? So again, after you cancel things out, you would have x plus 2 squared and then x plus 3 squared. Okay? So that's how you put the 1 into the finalized reduced equation. And then you would find out that it is 3 squared over 4 squared. And 3 squared over 4 squared is simply 9 over 16. So so somewhere right here in the middle, that would work. Okay, 1 comma 9 over 16. So somewhere between 0 and 1, that would work. That was where the hole is. Can you tell where the vertical asymptote is? X equals to -3. Can you tell where the horizontal asymptote is? Y equals to 1, because when you think about x plus 2, x being so big, the plus 2 wouldn't matter. The plus 3 wouldn't matter. So you just x squared over x squared, which reduces to 1. Okay, so let me go ahead and draw these two asymptotes. So x equals to -3. And then y equals to 1. And now here's the main thing. Here's the main thing right here. Now, there are a couple of things I want to talk about here. Can you see the square for both numerator and denominator? Yeah? Yeah. So that means around the vertical asymptote, the graph should come from the same direction. Now, with the numerator, we can also talk about the x-intercept. Where's the x-intercept? The x-intercept will be when the fraction equal to 0 or the numerator to be 0. So that means the x value of the x-intercept must be -2, because that's what makes the numerator 0. That's what makes the whole fraction 0. That's what the y. That's how the y value becomes 0. So -2 comma 0 right here. Where's the y-intercept? You put in 0 for x. So x comma, and numerator will be a 4 because of 2 squared. Then denominator will be a 9. So somewhere right around here. Okay, now, so we got squares. And what did we say earlier? Anything squared must be positive, right? And since the numerator and the denominator are both squared, can we say the y value is always positive? Can you see how the y value is always positive? Because the numerator is squared, the denominator is squared. There's no way they can become a negative. And therefore, with this understanding, that's how we can draw our graph, because we know that it has to stay on the positive territory. And therefore, we have this, okay? We have this. This would be our graph. So there would be a bounds on the x-intercept, at the x-intercept, because of the square next to x plus 2. there will be, the graph would come from the positive direction, right around the vertical asymptote because of the square of the denominator. So that's how we will approach these questions. Okay, with the square in the numerator or a square in the denominator.